Hello, hello. Hi, my friends. This is Mr. Polly, and welcome to Grading Your Own Quiz. Yay! I think I remember put point values and everything. We'll see. If K is smaller than 1, what is favored, reactants or products? Remember, K is products over reactants. K is smaller than 1, reactants are favored. That's why it would be smaller than 1. Write the K expression for the reaction above. All of these are gases. They're all going to be in there. It's products over reactants. But it's unbalanced, you dirted dog, you dirted dog. So I need to balance it and put in these. 1 point, you do need these. These are all or nothing points. So, yay. A system has a Q of 13 and a K of 0.13. Use the collision theory to explain which way the reaction will shift. So Q, just like K, is P over R. But Q is too big. What that means, instead of too big, I'm going to have too many products. Too many products compared to K. So products collide more often. So reverse reaction is, whoops, not if. Reverse reaction is faster. So it shifts up faster than forward. So shifts left. Left hand side. What do you need to get the point? You need to have the word collide. You need to have reverse reaction is faster than forward, and you need to have the shift part. All of those are required for 2 points. So if you have 3 things, you get +2. If you have 2 of those, you get +1. If you have 1 thing, you get +0. Aww. At equilibrium, which the following are true, there may be more than one. The rates are equal. The rates are equal. True. The amounts are equal. False. The amounts are constant. True. The reaction stops. False. 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 So +3 if it's perfect. +2 if A or C. And, +2 if A, C, and extra. And then +1 if missing A or C. All right. At equilibrium, 2 moles of this and a 2-liter container. Okay. So you know I hate my moles. So right away, 2 moles, I got to make that into molarity. 2 divided by 2. Right, so I'm dividing by. So this is 1.00 molarity. 1.5 divided by 2 is 0.75 molarity. I can't believe I put that in a calculator. Dividing by 2. And 0.75 divided by 2 is 0.375 molar. Are present in equilibrium. Show the work to calculate the value of KEQ. Okay, so these are all at equilibrium. So because they're at equilibrium, I'm just going to write my K expression. K is CO2 times NH3 squared. Uh-oh, this is a solid. So that means that's it. CO2 is 0.375. NH3 is 0.75 squared. Uh-oh. 0.375 times 0.75 squared, 0.211. And that's the answer. You got to have that with work for 1. At a particular time t, that means I'm looking at Q. That means I'm looking at Q. SO2 was found to be 0.35. Cl2 was 1.5. And SOCl2 was that. KQ, this temperature is 25. Show work to calculate the value of Q. So Q is products over reactants. So SO2Cl2, 0.5. Uh-oh, no coefficients. 1S, 1S. 2 O's, 2 O's. Good, it's balanced. So products over reactants. SO2 was 3.5. And Cl2 was 1.5. 0.5 divided by 3.5 divided by 1.5 is 0.095. K is 25.8. Is the system at equilibrium? No. Q and K, 0.095, and K is, K is 25.8. So Q is less than K. So remember, this is products over reactants. So Q is less, so I have too many reactants. Which way will it shift? Right hand side. So again, this is worth 1. This is worth 1. I want to maximize products. What do I want? What do I do too? I'm going to make sure I shift it to the right hand side. Negative 67 kilojoules means I put plus 67 kilojoules over here. What do I do to temperature to shift it to the right hand side? I have to decrease temperature. What do I have to do to pressure? So pressure, I need to shift to the right hand side. I need to increase pressure to shift to fewer moles of gas. You only need to say down, up. Concentration of chlorine, increase it. Okay? State where the following shift will make the system lighter red or darker red. If I remove FeNO3 taken 3 times, that would shift to the left, lighter. Remove, replace. FeSCN is added. Oh, I added red. That's darker. That's the one you might miss. Remember, if you add the actual color, it gets darker. KNO3 is removed. Remove, replace. It's going to shift to the right-hand side. It'll be darker. Heat is added. Heat would shift it to the left. Heat is on the right-hand side. So it's going to be lighter. Volume is decreased. That only affects gases. No effect. And each one of those is worth a punto. So we're looking at +5 overall. All right, the curvy graphs. Which of the following best represents the graph at t equals 10? So at 10, I added, notice how this is the reactant. This is the product. Oh, it says that. So I added a reactant. Here, if the temperature was decreased, that would have it shift to the right. So removing heat would shift to the right, and my reactant would go down. And then at 30, pressure increased. Well, pressure would have no effect. So right now I'm thinking it's A. Reactants are added. Temperature is decreased. Pressure is decreased. Oh, shoot. That means either one of them will work. A or B or both. This is my happy day where everybody gets 1. You get 1. I get 1. We all get 1. Yay. Oh, let's put it back on there. All right. How many times does the graph above show equilibrium? Here's the first one. Here's the second one. Here's the third one. That's +1. The reaction above has an initial concentration of 0.60. Give the equilibrium concentration of each substance. Ha is in equilibrium with H positive plus A negative. Initial concentration of 0.60. Give the equilibrium concentration of each. 0, 0, minus X plus X plus X. 0.6 minus X, X, X. K is H positive, A negative over Ha. Ha. Substitute. 2 E negative 5 is X squared over 0.6 minus X. Let's solver that bad boy. X equals math up, solver up, clear. X squared divided by quantity 0.6 minus X closed quantity minus 2e negative 5. Enter. Guess it's a small one, so 0.001 alpha. Enter. X equals 0.00345 molar, which that equals H positive equals A negative equals 0.00345 molar. You need that. And 0.6, oops, clear. 0.6 minus X is 0.596. So Ha equals 0.597 molar. You get a little bit of wiggle in there, but you need both of those for 1 punto. H2 has an initial concentration, so here we go again. H2 plus Br2 gives me 2 HBr. They are all gases or aqueous. So H2 has an initial concentration of 0.8, and bromine has an initial concentration of 0.8. If the equilibrium concentration of HBr is 0.5, equilibrium concentration of HBr is 0.5. So this is 0. That means this is plus 0.5. That's 2x, right? So this is going to be half. Each of these are going to be half of 0.5. Minus 0.25, minus 0.25. 0.8 minus 0.25, 0.55, 0.55. So value K. K is HBr squared over H2 Br2 0.5 squared over 0.55 squared. 0.5 squared divided by 0.55 squared, and it's 0.826 worth 1. Boom, bada boom, bada boom, bada boom. So that, I believe, is 20 because every question was 1 point except for one. Yep. And so we are looking at, out of 20. So the only one that had, oh, no, that's not right. So we've got 20, 21, 22. So out of 22, give yourself a score out of 22. And give yourself a little smile and some love. You've earned it. Peace and love, peace and love. Toodles, my friends.